Hello, class. As we continue our great factoring video series, this is lesson F4, the greatest common. Best news of the day, I did not do a spiral review, so we can just skip that, and we don't have any properties of exponents. Jump right into the lesson. So probably don't necessarily need to write this down, but what is factoring? Factoring is simply the process of separating a polynomial back into the product. So we distribute or we multiply a polynomial times a binomial and we get this big long polynomial. But what if I want to go backwards into the separate pieces? That's what factoring does. And we have a special name, just like numbers that cannot be factored, numbers like 7 and 19 and 23, we call those prime numbers because they cannot be factored. Polynomials, which cannot be factored, are also called prime. So how do we find the greatest common factor? Probably should write these steps down. Very first thing, we are going to look at the coefficients first, so the big tall numbers out front. What do all those numbers have in common? Step 1. Step 2. A variable must be in common to all terms to have a greatest common factor. So if there's an x in the first two terms, but not an x in the last term, then you cannot factor that x out. Step 3, if a variable is common to all terms, take the one with the smallest exponent. So if you have an x squared and an x, you can't take out an x squared because you don't have x squared in another term. We're going to divide each term by the greatest common factor. And then we're going to rewrite that. The greatest common factor goes right here on the outside. Don't know how to get back to that previous screen. Nope, that didn't work either. So anyway, the greatest common factor always goes on the outside. I'll write that step out here. The greatest common factor goes right here. And then what's left of the polynomial after we take out the greatest common factor will go right here. So let's look at example 1. Always ask yourself, if you're factoring, I don't care what you're factoring, question number 1 is always, does the polynomial have a greatest common factor? So when I look at this polynomial, I'm like, oh yeah, I'm looking at 6 and I'm looking at 24, and I realize that 6 and 24 both have a 6 in common. So 6 is my common factor, and that's going to come out front. For now, because this is still pretty new to you guys, you're going to divide every term in this polynomial by 6. And this step right here is required. You have to do that right now. So 6 divided by 6 is 1, and that just leaves you with an x. Bring down your sign. 24 divided by 6 is 4. So the factored form of this binomial is 6 times the quantity x minus 4. Example 2. We have 4y squared minus 40y. So I look and my GCF is 4 out of my constants, 4 and 40. I have a y squared and I have a y. So I'm going to take the polynomial with the smallest degree, which is y to the first. So I'm going to take out a 4y, which means I'm going to come up here and divide everything by 4y. So when I look at this, 4 divided by 4 reduces to 1. A y squared over a y to the first leaves me with a y. Bring down my minus. A 40 divided by 4 is 10, and y over y reduces down to 1. Now, this is a little math magic here, but you could technically check this by the distributive property. So here we get 4y squared. 4 times 10 is 40y, and that should match your original problem. Crazy stuff. All right, so example number 3 looks a little bit longer, but remember this is a process. We're going to repeat the process over and over and over again. So we have 20r to the 4th s cubed minus 15r s squared minus 10 or plus 10 r squared s to the 5th. So I look at 20, I look at 15, I look at 10, and I have to determine what all those have in common. They actually have a 5 in common. So I'm going to pull a 5 out to the front of my problem. Then I look at r to the 4th, r and r squared. Remember, you have to take the smallest one out. I can't take 4 r's out if I really only have 1 r. So I'm going to take out a single r. And then you have s cubed, s squared, and s to the 5th. So if I choose the smallest power, I'm taking out an s squared. So when I look at this polynomial now, I'm going to take each term in this polynomial and I'm going to divide it by 5rs squared. Divide by 5rs squared. Divide by 5rs squared. So take a minute, hit pause, work through this problem, and we'll check your answer when you return. Wow, you guys are amazing. That was so fast. So let's look at this. Here, I'm going to take my number and divide it by my number. So when I do that, 20 divided by 5 is 4. I have r to the 4th, and I have an r. If I cancel those, I'm left with r cubed, and s cubed over s squared is simply s. I'm going to subtract. I'm going to come to my next polynomial right here. I have a 15 divided by a 5, which is 3. I have an r and an r, which cancels each other out and reduces down to 1. And an s squared over an s squared also reduces down to 1. 10 divided by 5 right here is 2. R squared over r reduces to r. And s to the 5th over s squared is s cubed. All right. One more problem today. It's an error analysis problem. So at this point you can hit pause. I just want you to really look at the student's work, and I think he made or she made 2 mistakes in this particular problem. So see if you can figure out what those mistakes are and be ready to start the discussion here when we come to class tomorrow. Have a wonderful evening, and I will see your beautiful smiley faces soon.